Hey everybody, welcome back. Today we're going to be talking about lesson 4.8, the Pythagorean theorem. This is a nice little theorem named after a beautiful, my goodness, I shouldn't say he's beautiful, a man named Pythagoras. Okay? Alright, so this is an awesome theorem. The theorem is beautiful itself because it's a fantastic theorem. All right, so that's what we're going to learn about today. So let's go. All right, so the very first four, you're going to use a calculator. Today you're going to be using a calculator all day. So hopefully you have a calculator handy. You're going to use a calculator to find each value. Round to the nearest hundredth. All right? So round each of these to the nearest hundredth. Okay? Go. All right, so the very first one, square root of 30. Answer, 5.48. 5.48. That is a 5. 5.48. 2, square root of 14. 3.74. Again, I'm rounding to the nearest hundredth. 3, square root of 55 is 7.42. And the last one of 48, square root of 48 is 6.93. All right, so that's what we have today. We're going to be using this a lot. Okay, using these square root and that square root button a lot. So do have a calculator handy, like I said earlier. All right, buckle up. Let's go. We're going to be using the Pythagorean theorem and its converse. Oh, it's converse. What in the world is converse? I'll teach you. All right, so please pause and write this down, so you have this down, and also write everything. So even write this stuff down in this box where it's a squared plus b squared equals c squared. Okay, so write all this down. Go. All right, so Pythagorean theorem. One thing you need to know is this works with right triangles, not all triangles, just right triangles. How do you know it is a right triangle? Well, it's got a 90-degree angle here. Makes it a right angle for a right triangle. All right, inside a right triangle, the two bases are the two legs. When we have our two legs, the longest side is known as the hypotenuse. Okay, again, the longest side is known as our hypotenuse. That is your length here. The longest side, the side opposite of our 90-degree angle. Notice my 90-degree angle is here. Opposite is my hypotenuse. It's the opposite side of my 90-degree angle. The other two are known as bases. So we're going to be using this theorem, and this theorem, like I said, works only with right triangles, and it's a squared plus b squared equals c squared. That's the Pythagorean theorem. Pythagorean theorem, and it is like a law in math. Theorems are like laws. It proves to be true all of the time. Okay, again, this is a right triangle, so it needs to be your right triangle. I've repeated myself a lot. So let's try a couple of problems. All right, so I want you to pause this right now, write these triangles down, and then I will explain the first one, and then I'm going to have you do the second one. All right, so pause to write it, and then I will explain the first, you will do the second. So go. Okie dokie. All right, so this one, notice it is going to be, we are going to be relating the sides of a right triangle. Why is it a right triangle? That little box there tells me it's a right triangle. Okay, so I know according to my right triangle, my Pythagorean theorem, that if I take a leg and square it, so a squared plus b squared, it is equal to c squared. Okay, so a squared plus b squared is equal to c squared. Now, what we have to figure out is we have to figure out which is our a, which is our b, and what is our c. Remember, our a and our b are our legs. Okay, those are the legs of the triangle. The legs of the triangle, it does not matter which one you plug in here because they'll both be the same, but they're going to be used as 3 and 4. 3 and 4 are our legs, and our hypotenuse, our C, is the thing opposite, is the side opposite our right angle. Okay, so if I plug these in, and again, it does not matter if 3 is my A or if 3 is my B, as long as you understand that those are my legs and that I plug them in. Okay, so I get 3 squared plus 4 squared equals C squared. And I plugged in C here because that's where it went. Now, as I do this problem, I just start simplifying and I'm going to solve for C. So what's 3 squared? 9 plus 4 squared? 16 equals C squared. 9 plus 16 is what? 25 equals C squared. Now, I got C all by itself, but I still have an exponent on that C. So it means C times C, right? The way we undo a square, is by taking the square root. Take that square root of our C. And we're going to be dealing with the principal square root, or that positive square root. So, what is C? The square root of 25 is 5. Some of them might not always pan out to be as perfect as this one, as a 3, 4, 5 triangle, but it will work if you use that square root button in the end. Okay, so you need to use that square root button. So what I want you to do is try your next triangle. So try the 5, 7, and C triangle. See what you come up with. Again, using this equation, just like I did before, break it down into steps and solve. So pause, go. All right, here we go. So again, what is the theorem? The Pythagorean theorem. What is the Pythagorean theorem? A squared plus B squared equals C squared. Get used to that theorem. You're going to have it memorized. Know it, learn it, love it. Okay, so Pythagorean theorem. A squared plus B squared equals C squared. What is my A and my B? Well, that's going to be my 5 squared plus 7 squared equals C squared. All right? All right, now we're going to answer these simplified. I get 25 plus 49 equals C squared. When you combine 25 and 49, you will get 74 equals C squared. Notice 74 is not a perfect square, so I may not know that right off the top of my head. But I do know how to get rid of that squaring symbol. How do you do that? Square root. Okay, you take the square root of 74. That basically gets rid of that square, and we are rounding to the nearest hundredth. How do I know that? It's up here, up there, up top. Tells me round to the nearest hundredth. So, if I look at this, it is C is equal to 8.60. 8.60. Okay? All right, that's the Pythagorean theorem. Let's work on another one. All right, so you can leave the directions because you just wrote those directions on the previous problem. If you did not write it on the previous problem, I'd write them now because they're at the top. Okay? With this, we have to find our length. The length of the legs. So we won't be able to find our hypotenuse, but I want to see if you can find the length of the legs. If you can't, try to find your hypotenuse. So pause now. See if you can figure this out. All right? See if you can figure this out. Pause. Go. All right? Now, the way we figure out the length of the legs. Now, I know we haven't talked about this, so if you haven't gotten it yet, don't worry about it. All right? So the way I find the length of my legs, I know on my y-axis here, I want to go start at this point and go down to this point, and I want to find my distance. My distance is going to be how many points I went down. Well, 1, 2, 3, 4, 5, 6. I went down 6 units. Okay, now I need to find my other legs. That is 1, 2, 3, 4, 5. 6 and I have 5. Notice that diagonal line there. Okay, that is my hypotenuse. How do I know it's my hypotenuse? Well, I know that this angle right here is my 90-degree angle. Okay, because it came at, those lines are perpendicular to each other. Now, this is my hypotenuse, that far side. I can't just count the number of boxes because that doesn't work because we have a diagonal line. Okay, so how do I figure out my hypotenuse? Well, if that's my C, I plug in 4a squared plus b squared equals c squared. I plug in my legs and my hypotenuse. All right, so if you haven't gotten this far, I want you to pause and go. All right, here we go. So now, it's c squared plus a squared plus b squared equals c squared. Plugging in these points, I get 36 plus 25 equals c to the second. 36 plus 25, 61 is equal to c squared. How do you get rid of that exponent? Square root of c, and the square root of 61 is 7.81 equals c. How did I know it's 7.81? Well, it tells me round to the nearest hundredth, round, nearest hundredth. Tells me right up there. So make sure you understand, okay, make sure that you read those directions. All right? All right. All right, so now, oh my goodness, Mr. Sheeman, what are you doing? Okay, this time, if you look at this, you have an unknown side. Notice here, we're looking for our B. So this is where you're going to have to manipulate that variable a little bit. Okay, so we haven't talked about this, but I want to challenge you. I challenge you to see if you can come up with this answer. If you can't come up with this answer, that's okay. I just want you to try. If it's the incorrect answer, write down the correct answer when you get to the end of this problem and after I explain it. Okay? All right, so pause now. Give this one a shot. All right, so if you look at this, we are not given a C, we're given a B. So again, in order for us to find a right triangle, we can still use the equation of a squared plus b squared equals c squared. Okay? Now, it tells us we're going to be finding one of our legs. That leg looks like it's B. We're going to be finding one of those legs. So I know what A is, and I know what C is. A is my other leg. C is my hypotenuse. Remember, opposite right angle. Okay, so now I'm going to plug in 10 squared plus b squared is equal to 26 squared. I just plug in what I know. All right, so now as I do this, when you square 10, what do you get? Well, 10 times 10 is 100. So 100 plus b squared equals 676. That is 26 to the second. 676. Okay, now, when I look at this, how could I solve for b squared? Well, I need to get rid of that 100 first. Get rid of the 100. How do you get rid of the 100? I want to bring this 100 over to the right side. How do you get rid of it? Well, just like equations. Subtract. Subtract 100. Subtract 100. Okay, so I get b squared is equal to 576. Now, I'm continuing on this problem. How do you get rid of that squaring symbol? Square root. Easy question, Mr. Sheeman. Square root. So you find the square root of 576. B is equal to 24. 24. 24. Okay? Plug these things in for your equation. Right here. Simplify the equation. Bring your numbers together and find your answer. So there's 4 steps here. 1, 2, 3, 4. All right? Try this one on your own. Pause. Go. All right. Here we go. 12, 4, B. How do I find out this problem? What do I use?
Right here.
Pythagorean theorem. What is the Pythagorean theorem? Tell somebody next to you. What is the Pythagorean theorem? Go. Now, I hope you told them it's a squared plus b squared equals c squared. Very fast. Okay, plug in what you know. Well, I know what a is. It's 4. Squaring that. Do I know b? Nope. It's b squared. Do I know c? Yep. It's 12. How do you know that? That 12 is your c squared. Opposite my right angle. Opposite my right angle. Okay, plugging in or simplifying a little bit. 16 plus b squared equals 144. Okay, what do I have to do? Well, I have to bring that 16 over. So I get b squared is equal to 128. Subtract 16 on both sides. Whoops, forgot the step. Equals 128. How do you get rid of the square root? Oh my goodness, Mr. Sheeman, you told me the answer. How do you get rid of the square? Find the square root. What is the square root of 128? It is 11.3. Round to the nearest tenth this time because that's what the directions told me on the previous slide. I apologize if you rounded to the nearest hundredth. If you rounded to the nearest hundredth, it would have been 11.31. 11.31. All right, one more slide here. Last slide of the day. Actually, this is the last slide in chapter 4. Chapter 4. Last slide in chapter 4. Okay? Read through this. Okay? As you do this, see if you can make a right triangle out of the plane's path. Okay? So write this down. Reread it. Think about it. Try to see if you can make at least the start of a right triangle. And see where you get. Okay? So pause now. Go. All right, so it says 2 airplanes leave the exact same airport at the same time. The first plane flies to a landing strip 350 miles south, while the other plane flies to an airport 725 miles west. How far apart are the 2 planes when they land? All right, well, the very first thing is we've been dealing with Pythagorean theorems. We need to have a right triangle. They both start at the same point. There's my airport. Oh, that's an ugly airport. Big dot, ugly airport. Okay? Now, first one flies south. Think about a compass. That's south. It's flying south for the winter. Maybe not for the winter. Maybe just for a day. And it flies south how far? 350 miles. Okay? The other one flies west. It's going out west. Flies west. How far? 725. Now, why did I start at that same point? Because they left the same airport. Okay, then they landed. We need to figure out where they ended. This one ended here. This one ended here. How far apart are they? Well, we need to figure that out. Oh my goodness, Mr. Sheeman. What did you do? You made a right triangle. You made a right triangle. Mr. Sheeman, you made a right triangle. Yes, I did. Okay, how do you solve from a right triangle if I want that unknown side? Pythagorean theorem. Yes, Pythagorean theorem. Here we go. Pythagorean theorem. A squared plus b squared equals c squared. I made a right triangle. I can plug those numbers in. 725 squared plus 350 squared equals c squared. Okay? Now, 725 squared. Anybody know that off the top of their head? I do. It is. It's a really big number. 525,625. Then, do you know what 350 squared off the top of your head? 122,500 equals c squared. Okay? Add those two together. When you add 525,625 to 122,500, you get 648,125 equals c squared. Okay? Now, how do you figure out your answer? It might not be a perfect answer, but it might not be a perfect square, but we can figure out how we get rid of that squaring. Well, square root. Your answer, C, is equal to, I'm going to go to the nearest mile, which would be 805. What does this mean? Well, they were 805 miles apart. And I can use my Pythagorean theorem to show what that is. Again, I just drew a little diagram. Sometimes drawing a little diagram helps, and it helps out a lot because you can visualize that right angle or that right triangle. Okay, that's all I have for you today. It's just the Pythagorean theorem. I hope you enjoyed this video. Have a wonderful night. Bye.